Hey everybody, today we're talking about the Algebra 2, 2.1 to 2.5 review. So this is the review for all the classes. So it doesn't really relate to Honors Period 1. It's just where it was created, like I've said before. So the first one is solve the inequality and graph the solution. So this is all the way from 2.1 to 2.5. The first thing you're going to want to pay attention to is that's a greater than sign, and so we thought great or. So you say negative 7x plus 3 greater than 8 really means negative 7x plus 3 greater than 8 or negative 7x plus 3 less than negative 8. So you basically have to change your direction and change your sign. Now we're going to subtract 3 from both sides. So negative 7x greater than 5. And here I'm going to divide by negative 7. And when you divide by a negative, you change your direction. So then negative 5/7 like that. On this side, I go minus 3, negative 7x less than negative 11, and divide by negative 7. Again, change your direction, and you go 11 over 7. So smaller than negative 5/7, or, so first off, it's got to be the one with or because it's the greater than sign, so it's B. And it says smaller than negative 5/7 or greater than 11/7. Now, as a decimal, let's see, negative 5/7, control enter, that's negative 0.7. It's approximate. And 11/7 is approximately 1.6. So you want smaller than negative 0.7 and greater than 1.6. And so that's A. Remember, this and this would have been OR graphs. This and this would have been AND graphs. This one would have been all reals, and this one would have been no solution. So between the two OR graphs, this one is in between 0 and 1, and this one's between 1 and 2. And so that's how we know it's that one. Alright, our next problem says graph the equation, then describe the transformation. So first we're just going to graph this. Add graph, negative 1/6, absolute value, x. Okay, so it's down and it's like that. And this one's down, but it's too narrow, and so it's this one. Then it says describe the transformation. So there's a negative sign in front, so you do want it reflected across the x-axis, which is in 3 of them. And you want the 1/6. The 1/6 in front represents a vertical compression. And again, with the negative sign right there, it reflects the x-axis. So vertical compression and reflected across the x-axis. So number 2 is C. It's B followed by C. this one, it says solve the absolute value equation. So you subtract 18 from both sides. So you have 7n minus 4 equal to negative 14. So on this problem, you would set it equal to the negative and positive. Oh wait, you can't do that because an absolute value can never be negative. So because of that, it's no solution. An absolute value can never be negative. All right, on number 4, begin by graphing the function absolute value x, then use transformations to do this. So here's your list, and the first one is there's a negative sign in front, and so that's the reflect across the x-axis. Remember, if it's a checkbox, you need to select all that apply. In this case, you're also going right. So this reflects the x-axis and translate right, or horizontal translation, or horizontal shift. Those all mean the same thing. Horizontal shift or horizontal translation mean the same thing. Okay, so what we're doing is flipping it, and all of them are flipped, and then we're going right one. So negative absolute value x minus 1. So that's like that. Now all these graphs are going negative 10 to 10 and negative 10 to 10 vertically also. And I want to focus on where the vertex is. Looks like 1, 0, but let me find out for sure through the maximum. And that's 1, 0. So it's not this one, it's not that one, and it's not that one. So that's A, based on the 1, 0. Okay, on this one, you can work this table out by hand, which is probably the quickest way. So this one, think negative 1 plus 10 is the same as 10 minus 1, which is 9. Then this is 10, 11, 13. So that's probably the quickest way, but you can still do it through the calculator. So we go absolute value x plus 10. And looks like the left side is negative 20 on a few of them. Now if you can't get to where the number is, you can either move the label like that and do it, like double click it, or you could have gone to menu, window, settings, and typed in negative 20 for x. Now this one has the 14 for the biggest one, so I guess let me do that too. Positive 14 for y max. So it's like that. So that matches the B graph. Again, if you want to, go to your analyze graph, go to your minimum, and go between here and here, and you can see that's negative 10, 0. And these are counting by twos, I believe. 2, 4, 6, 8, 10. So scale factor is 2, counting by twos for x. All right, the next one says graph the absolute value inequality. And so on this one, we could go through all the steps, but if you want to use the calculator for this, well, first I want to clear out what's there. So I'm going to go to New Document. Then, to me, the easiest way to work this is to go to Graph Entry, but then change it to Relation. So here you can actually just leave it exactly the same way. 3 minus y. So I just use that y button. And now I need greater than, so I go Control equal greater than the absolute value 4x plus 3. Notice I'm not even bothering to solve for y. And I see it's this one. So that's going to be this one. Wait. Okay, this one has negative 10 down here. This one has negative 4 down there. So let me go to my window and see which one between them. Window settings. If I have this as negative 10, that's higher up, and so it's not B. Also, we know it was not B because these are solid lines, and this is a not equal to. It's a greater than, not greater than or equal to. So now you're down to, is it this one or this one? So I want to look at negative 4. These two look identical. I think the difference is that on the original, when it was printed, this one would be shaded this way, and this one would be shaded that way. And so we need to choose C. Because other than that, you know, they look identical. So when I did the printing of this, it didn't come through right. So this one would have been the 3 minus y greater than 4x plus 3. And if all I did was I changed this to a less than sign, then it would have shaded everything else. So this would have just been less than 3 minus y less than absolute value 4x plus 3. So notice when it has negative y, the less than becomes greater than. So that's why it's above. And this one, notice the negative y greater than becomes less than, so it's below. So you're going to have to see the difference, and I'll make sure that it's shaded if you have a paper test. Okay, our next one says, without graphing, identify the vertex, axis of symmetry, and transformations on the parent function. So this one, your vertex is based on what's in the absolute value, and so since it's an x plus 11, you're going to have negative 11, 0. So your axis of symmetry is x equal negative 11. So this is going to be reflect the x-axis and left 11. So this is 11 to the right, this is 11 to the left. So it's this one. Reflect across the x-axis and translate 11 to the left. The next one, solve the inequality, graph the solution. So we can add 11 and say 2x plus 1, the absolute value of that is less than or equal to 7. So this is a less than or equal to, and so it would be an and, which tells me it's not those two graphs. And you would have 2x plus 1 less than or equal to 7 and 2x plus 1 greater than or equal to negative 7. So I want to subtract 1, 2x less than or equal to 6, divide by 2, and so you get less than or equal to 3. And on this side, 2x greater than or equal to negative 8, then divide by 2, x greater than or equal to negative 4. So basically it's between negative 4 and 3. And so this is what goes up here. The solution is negative 4 less than or equal to x less than or equal to 3. And so between these two graphs, 1, 2, 3, this one's negative 3, 2, 3, 4, positive 4, 1, 2, 3, 4. This one's negative 4, 2, 3, and positive 3. So we would want C. So that's how close those two are to each other. But again, this is and, this is and, this is or, because these are two separate rays. This is the one with all real numbers, and this is the one with no solution. Okay, on number 9, graph the absolute value function, then analyze the domain, range, intercepts, and symmetry. So the first thing is we want to choose the correct graph. So we have 2 times the absolute value, x minus 4. And that 2 is going to be a vertical stretch, and that minus 4 is going to bring us down 4. So we now have a slope of 2, go up 2, right 1 repeatedly. So it's not the downwards ones. And this one is a little lower than that. This is the 0, negative 4. And this just looks like 0, negative 2. So that's why it's this graph. It's really important you get the graph right, because then everything else is based on that. Your domain would be all real numbers, and so we answer that in interval notation, like negative infinity, infinity. Then your range would basically be y greater than or equal to -4, and so that means we have a bracket -4, infinity. It's a bracket because it includes that number. And now we need the x-intercepts. Again, it looks like it's counting by 2's, and so that would be -2, 0, and 2, 0. You can find out for sure on your calculator, either through the table, like there's 2, 0, or through 0 of the graph. So analyze graph, then 0 of the graph. Between here and here is 2, 0. So you just move it like that. And then the other one's -2, 0. Then we need the y-intercept, and so we already know that's 0, -4. Remember to use an ordered pair. And now we need the axis of symmetry. And so it's based on the x value of the vertex, which is also the y-intercept in this case. And so this is x equals 0. The next one is solve the graph, solve the absolute value inequality algebraically. So this is one where what we did is we got the absolute value by itself first. We can do -11 to both sides. Y minus 11 greater than x minus 5. And it's a greater than, so it's going to be like hold on just a second. This one we end up putting our absolute value on the left side. Okay, so on this one, because it's x minus 5, we need to say when x minus 5 is greater than or equal to 0, then we have y minus 11 greater than x minus 5. And then we want to add 11 to both sides, so we get y greater than x plus 6. So that's this one. And this is for greater than or equal to, since we have x minus 5 equal to 0, this would be x equal 5. Like that. And so then we'd put the same number here. So I need to get the other equation as well. I'm going to say when x minus 5 is less than 0, y minus 11 is less than negative parentheses x minus 5. So we go y minus 11 less than negative x plus 5. Then we add 11, and we get y less than negative x plus 16, which is the exact same thing as that. So basically, you need to fill in the 5 and the 5 and choose the correct equations. Okay, that's number 10. Number 11, we want to divide by 4. So we get the absolute value 3x minus 6 equals 6. So what that does is it says 3x minus 6 equals 6, and 3x minus 6 equals negative 6. So then you're going to add 6 to both sides. So 3x equals 12, so x is 4. And this one, add 6 to both sides. 3x equals 0, so x equals 0. So your answers are 0 and 4. Okay, number 12. This little 1 with the parentheses around it means there's a choice. So we have the graph should be shaded right there. The first thing I know is it's going to be an x plus 2 right here. And this is one where the shading did not really show up. So this is going to have to be less than or equal to. So you either put it like that or you choose less than or equal to. Again, if you had a test on paper, I'd have to make sure the shading was visible. So what I did is I just looked at the graph and I got x plus 2. But again, like I've said before, you could factor out a 3. And so then you can think that's how I got the x plus 2. Alright, on this one we have a length of 8.53 and a tolerance of 0.21. So the 8.53 goes in this blank and the 0.21 goes in this blank. So now for your next step, it is less than because we're focusing on small values for our tolerance. And so we say x minus 8.53 less than or equal to 0.21 and, because if it's a less than, then it's an and, x minus 8.53 greater than or equal to negative 0.21. So now we want to add, so x is less than or equal to 8.53 plus 0.21, that's 8.74. And on this side, negative 0.21 plus 8.53, x is greater than or equal to 8.32. So think of it as 8.32 less than or equal to x less than or equal to 8.74. So 8.32 and 8.74. So don't just bring this number and that number down. They have this as the absolute value inequality because they have the absolute value signs, and this is the compound inequality, which means you're less than or equal to, and that it's an and. Okay, on number 14, it's a greater than sign, and so this is going to be an or. We just want to graph this. So we add graph, then go to graph entry relation and say y control equal, find greater than, absolute value, negative x minus 2, and then plus 2 is the vertical shift. So this is going to flip horizontally, move right 2, and up 2. So it's there, and it's graphed like that. So on this, let's go to our Analyze Graph, to our intersection. I meant to get to the minimum. Analyze graph, and then to get to the minimum here and here. That's negative 2, comma 2. Negative 2, comma 2. And then we want to say the slope is equal to rise 1 over run 1 in our case, because there's no number in front of x. And so up 1, right 1, up 1, right 1, and then from here, up 1, left 1, up 1, left 1. So because it's less than, because it's greater than, but not greater than or equal to, we need to use a dashed line. And then you could test a point, 0, 0. So you'd have 0 greater than, negative 0 minus 2 plus 2, 0 greater than, 2 plus 2, 0 greater than 4 is false, and so we shade on the inside. And again, the calculator told you where to shade also. Again, the only thing to really pay close attention to on the calculator is this is dashed lines, not a solid line. So that's how you do number 14. Number 15, it just says solve the equation. So on this one, you're going to want to add 4. So you have 3 absolute value, 4y minus 1 equal to 18. Then divide by 3. So the absolute value, 4y minus 1 equals 6. So then you're going to set it equal to positive 6 and to negative 6. Add 1, add 1, add 1, add 1. 4y equals 7, so y is 7 fourths. 4y equal negative 5, so y is negative 5 fourths. So you can put negative 5 fourths, comma, 7 fourths. Those are the two solutions. Also, to double check that there are 2 solutions to this one, it'd probably be a good idea to graph it. Menu, graph entry, relation, 3 absolute value x, 4x, minus 1, minus 4, equal 14. Whoops, made a mistake right there. Okay, it looks like I should have graphed this one instead. Absolute value 4x minus 1 equals 6. Okay, never mind. I remember what I do now. What I really needed to do was go to a graph and just say absolute value for x minus 1. That's my function 1. Function 1. And this is function 2. 6. So there I'm going to see I have two answers. I can go to intersect between here and here. That's your negative 1.25, which matches that one. And this is your 1.75, which matches that one. So those are your two answers. Okay, number 16, write an absolute value equation for this one. So first thing is it's down, so we start with the negative sign. And then we know our vertex is at 2, negative 1. So I'm going to leave a little space, and I have x minus 2 for going right to, and then I'm going to put minus 1 over here. So what we need is the slope on the right side. We do know it's negative, so then just count, bring this down. One, two, three, 4, 1. So this went down 4, right 1, so this is a negative 4. So your slope is negative 4. Okay, on the next one, graph the equation 5/4 x minus 2, and so when you graph this, that's going to be b. Absolute value 5/4 x minus 2. Okay, so that's the B graph based on where the vertex is. And this one, the negative 2, would indicate that it's right to, and when it's inside, that's going to be horizontal. And it's basically the opposite of when it's on the outside. When it's on the outside, it's a stretch. When it's inside, it's a compression. So this one is going to be compressed horizontally and shifted to the right. So that's E. On the next one, we're saying negative absolute value x plus 2, and we need to pay attention to the interval 0, 6. So the first thing on this is graph negative absolute value x plus 2. And then from 0 to 6, the 0 side is going to be the max, So think of this as f of 0, and this is f of 6. And you can go to your table, and for 0 it's 2, and for 6 it's negative 4. Remember, your minimum always has to be smaller than your maximum. And this was the B graph. Because this is above, and that one was below. So this is from the 0 to, because this one is below. Alright. This one, without graphing, identify everything. So this one would be 6, 5, because you change your sign of that one, but not this one. Your axis of symmetry is x equals 6, and this is going right 6 and up 5. And so that's C. 6 units to the right and 5 units up. And then our last one, we need to solve this equation and check for extraneous solutions. So we say x minus 4 equal 4x plus 8, x minus 4 equal negative parentheses 4x plus 8. So I'm going to subtract x. So I have negative 4 equal 3x plus 8. Then I'm going to subtract 8. The reason why I chose to subtract x is because 4x is bigger than x, and so I kept the 4x where it was. So I subtracted x from both sides to get 3x. Now I have to subtract 8, so I have negative 12 equal 3x. And then we divide, so we get negative 4 equal x. Then on this side, the first step would be distribute. So we distribute that minus sign out. And then this is a negative 4x, and so I want to add 4x. So I get 5x minus 4 equal negative 8. And then add 4. 5x equal negative 4, so x equal negative 4/5. Now, only one of these, is it one solution or two? So to me, the best way to do it is to graph your original. Add graph. And we go absolute value x minus 4, and then you have 4x plus 8, and so it's only going to hit in one spot because that's a line. Then you go menu, analyze, intersect between here and here. It's negative 0.79 repeat, which is really negative 0.8, and that matches negative 4/5. So negative 4/5 is your only answer. Alright, so that'd be the end of the video.